Now let us define indeterminate form. What is the meaning of indeterminate form? Indeterminate form are the forms in which the limit does not exist. That is the form of 0 upon 0, infinite upon infinite, 0 dot infinite, 0 power 0, infinite to power infinite, infinite to power 0, 1 to power 1 to infinity, infinite minus infinite. That are the indeterminate form where the limit of the functions does not exist and the form makes these types of forms. Okay, now first form is infinite upon infinite form, right? Limit extending to infinity, x minus sin x upon x plus sin x. After taking limits we have the form of infinite upon infinite, right? Now how do you know that these form, we want to remove these forms, right? So for removing this form and taking the limit of these functions and existence of the limit, we want exist of the limit, right? So we take some tricks, that is, after taking the x in factoring form, this gives you 1 minus sin x upon x, 1 plus sin x upon x. After taking the limit, it gives you limit extending to infinity, it is 1, then it is 1. Limit extending to infinity sin x upon x, it is 0. Limit extending to infinity 1, it is 1, and limit extending to infinity sin x upon x is equals to 0, right? So 1 minus 0 upon 1 plus 0, this gives you 1. That is the form after removing infinite upon infinity form to existence of the limit, right? Now we have second form, 0 upon 0 form, right? What is the 0 upon 0 form? If you have x square, this type of function, x square minus 9 upon x minus 3, for taking limit, if you take limit at this function directly, that gives you 9 minus 9, it is 0, 3 minus 3, it is 0, right? So 0 upon 0. How to determine? We want to determine the limit of this function, but this is not exist, it forms 0 upon 0 form. So after taking some other tricks, what is the trick? It is, if we have factorized this functions x minus 3 to x plus 3 upon x plus 3 and so on, that goes to cancel out. So this gives only limit extending to 3 x plus 3, right? This gives you, after taking limit, it gives you a limit which is 6. So it is indeterminate form, but it is determinate form. This gives a other way of solving, that gives you determinant form. So firstly you seen that there exists no limit, but after taking some tricks, you give a limit of existence of the limit, right? So this is the indeterminate forms. Now we have the function 3 minus x under root x square plus 9 upon x square, right? Now after taking limit, it gives you 3 minus 3, it is 0, and this is 0, right? So how do you think that we have to remove this form? So for removing this form, we introduce new form, that uh, conjugate form. Using conjugate form we have solved this. So after taking conjugates of this is 9, taking gives you 9 minus x square minus 9 x square 3 plus under root x square plus 9, right? So this cancel out, this gives you x minus x square upon x square 3 plus under root x square plus 9. This after cancel out, this gives you minus 1 upon 3 plus under root x square plus 9, right? So limit taking limit of this, limit extending to 0, this gives you 0 plus 9, this gives you 3, then 3 plus 3 is equals to 6. This gives you existence of limit. This limit exists where this function is not existence of the limit, because this forms a indeterminate form, right? Now there is function infinite minus infinity form. What is the functions which we have infinite minus infinite form? First function, we have taken that limit extending to 0 plus 1 over x minus 1 over sin x, right? This is the form of infinite minus infinite. How it is infinite? If you take limit this becomes infinite. If you take limit of this, limit extending to 0 plus, this gives you infinite. So sin x is 0, at 0, this gives you 1 over 0 is equals to infinite. So this gives you infinite minus infinity form. So how do you solve this for existence of the limit? After solving this, you have, after we have solving this, sin x minus x upon x sin x, right? Now take the limit of this. Sin x is sin 0 minus 0 upon, this forms a 0 upon 0 indeterminate form, right? So this is not good, because we want a limit, right? So when we take the derivative of this L'Hospital rule, right? What is the L'Hospital rule? L'Hospital rule is that the numerator you have to derive and denominator you have to derivate also, then take the limit. Okay, now after derivative of this is cos x, this is 1, this gives you sin x plus x cos x, right? So after taking limit, this gives you sin cos x, cos 0 it is 1, 1 minus 1 it is 0, sin 0 it is 0. Then it is also given to, this also given 0 by 0 form. So if this also becomes indeterminate form, so now repeat the L'Hospital rule. This gives you minus sin x upon 2 cos x minus x sin x. So after taking the limit, sin 0 it is 0, but cos x cos 0, this gives you 1, and this goes to 0. So this is 0 by 2, that is the limit is 0. So there exists a limit. After removing and taking other forms of the L'Hospital rules, this gives you after limit. Now the fifth is I is equals to 0 comma infinity. This is the interval we have given, and the form of this is 0 dot minus of infinity form, right? So how do you know that it is the form of this? Then limit extending to 0 plus it is the function x log x, right? Now if you take the limit 0, this is 0, limit log of 0, which does not exist. Okay, so this is the indeterminate form which we do not exist, right? So limit extending to 0 plus log x, it takes types of 1 over x, right? Now limit extending to 0, 1 over x, after taking L'Hospital rule, 1 over x minus 1 over x square, removing it gives you minus of x, taking the limit, this gives you 0, right? Now this is the function x to power x, right? As x to power x, it is the form of 0 to power 0, right? This is the indeterminate form of 0 to power 0. As we know that x to power x is we rewrite it e to power x log x, right? So continuity of a function, we know that the continuity of the function y is to e to power y is continuous at y equals to 0, e to power 0 is equals to 1. So this is continuous function. So after taking this e to power 0, what is y? X log x is y. If you take e to power 0, that is gives you 1. So limit exists of this function, right? Now 1 की power infinite form. What is the 1 की power infinite form? 1 plus 1 over x की whole की power x. If you have this function, this gives you limit extending to infinity. When you take limit extending to infinity, this gives you 1 की power infinity, right? So what we should do that for this function, this gives you determinant form. So we take that this taking log e to power x log 1 plus 1 over x, right? This makes this. So after taking limit extending to infinity, is gives you x log 1 plus x. This is limit extending to infinity log 1. We have solved this term only at this point. Okay, limit extending to infinity x log 1 plus 1 over x, this gives you log 1 plus 1 over x, and this is 1 over x, right? Now limit extending to infinity 1 plus 1 over x की whole की power inverse after taking L'Hospital rule. by L'Hospital rule. By L'Hospital rule, this gives you 1 plus 1 over x की whole की power inverse minus x की whole की power minus 2. This is gives you x minus x की whole की power minus 2, and taking limit of this gives you limit extending to infinity, taking limit of this gives you 1. As we know that e की power y is continuous at y is equals to 0 and y is equals to 1, then y is equals to 1, it is continuous. So the limit of this is 1. Okay, so e की power 1 gives you e. So this is the limit of whole of this function, right? Now this is the last form of infinite की power 0 form. This gives you limit extending to 0 plus x. Now we have this function, right? It is infinite power 0 form. Okay, now how to remove this form and making the limit sensible? Taking 1 over x in the denominator and taking L'Hospital rule, right? What you have to take? L'Hospital rule at this point, which gives you 1 over this gives you 1 over 1 plus x and 1 over minus 1 over x square. This gives you, after taking limit, it is 0, and this is e की power 0, which is equals to 1.